Hello, students. Hope you're having a good semester so far, and the test is coming next week. I wanted to go over these two questions, which were asked to me by email last week, and both of these questions are actually very good questions, important for the exam. So the first question was evaluate the limit from left and from the right. It's kind of an infinite discontinuity. If you plug in 9 into the denominator, so that's your function right here. So this one is your function. This guy is your function right here. So if you plug in 9 into the numerator, it's positive. If you plug in 9 into the denominator, it's 0. So it's a number over a 0 form, right? So it means it's an infinite discontinuity. At 9, the limits must be infinity or negative infinity uh, from both the sides. So so if I'm looking from let's see, let's factor first of all, if whatever we can. If I factor x from the denominator, I get this form, which is the numerator stays the same. I cannot cancel anything. And the denominator changes to x times x minus 9. So actually, it has discontinuity at x equals 0 and also at x equals 9. So if I if I plug in 9, let's, because the question was asking about 9 first. So if I plug in 9 into your question, if I plug in 9 here, I get a number over a 0 form, which is already discussed. It's a linear factor. It's something similar to like the reciprocal function 1 over x shifted to the right. Just look at this factor x minus 9. So what this is telling you is the function, overall function, behaves very similar to this factor right here around the point 9. Okay, so the overall function, this function f of x, behaves very similar to 1 over x minus 9 around the point 9. Now 1 over x minus 9, how does this behave? This is just the shift of your reciprocal function. This is my point 9 to the right by 9 units. So this behaves something like this function, right? The reciprocal function, it goes to negative infinity from the left and positive infinity to the right. Now, if everything else is positive, if all the other factors are positive at 9 or around 9, it means it exactly behaves like this. If all the other factors changes sign around 9, then it does not behave. It will flip the limits. So let's check the sign of the other factors in this function at the point 9. If you plug in 9 into the numerator, 5 times 9 squared, 13 times 9 plus 6, it's positive. If you plug in 9, you have to look at this factor also, x. If you plug in 9 in x, it is positive. So it exactly behaves like, so overall function f of x exactly behaves like 1 over x minus 9 around the point 9. So thus, the limit from the left, which is right here, is your negative infinity, and limit from the right is positive infinity. Okay. So if you want to look at the limits from the 0 also, 0 x equals 0 is also an infinite discontinuity. That will also have your limits positive and negative. So that's also an infinite discontinuity. So if I look at limit as x tends to 0 from the negative side, f of x, my given function, again, if you plug in 0 into all the factors except x, what will it give you? It gives you positive or negative. If you plug in 0 into the numerator, you get a plus 6. If you plug in 0, not the x, because that's my point of consideration. So leave x. 0 minus 9 is negative. I'm getting a negative factor. It means my function behaves like negative 1 over x around the point 0. It does not behave like 1 over x. It behaves like negative 1 over x. And how I got this negative? Because if I plug in 0 into the remaining factors in the question, except this one, except x, because that's what I'm considering, it is giving me a negative number. So the limits are going to flip. So it will be plus infinity on this side, and limit as x goes to 0 from the positive side, it's negative infinity. Okay, so if you want, we can plot this function on Desmos and see what's going on with this function. Give you 1 second. 5x square. Oops, it's not closing. Anyways, so let's move on to the next function. I'll see if I can close this and then try to plot it. The next question, which was asked by a student or by a colleague of you, was a function. This is the given function, f of x equals 9x square. The point of consideration is a equals -4. And the question was, find the equation of the tangent at this particular point, a equals -4. Now, f of x square, it looks like this. It looks like this 9x square. It's kind of a stretched version of x square, right? So this is my x square right here, 9x square right here. So you are looking at the point x equals -4. So let's say this is my x equals -4, right? So I'm going to draw or find the equation of tangent at this particular point. Now first, using definition of derivative, I need to find the derivative of this function. I think part of the question was finding f prime of a as well. So I need to find the derivative. So far, we haven't learned the rules. So I'm using the definition of the derivative, which is right here in this box. Okay, this is the definition I'm using. Limit as h approaches 0, f of x plus h minus f of x divided by h. Plug in your function. Your function f of x is 9x square. So that comes right here, 9x square. There's a negative in between this one. Now f of x plus h means 9 of x plus h whole squared. It's not 9 of x squared plus h squared. Don't do this. Okay, so 9 of x plus h whole squared. And when I simplify this whole squared, I get 3 terms, which is x squared plus h squared plus 2xh. I have used this formula. A plus b whole squared is a squared plus b squared plus 2ab. Okay, once I simplify, if I distribute my 9, these two terms will cancel out. I'm factoring in h. I'm left with 9h, h plus 2x divided by nh. Limit h approaches 0, so I need to cancel this, which will definitely cancel. I'm left with 9 of h plus 2x. Now limit h approaches 0, you just plug in h equals 0, and you get 18x. That's my derivative. This is my f prime of x for that function. So this is my f prime of x, which I just found using definition of the derivative. I'm finding equation of a line. So I'm finding equation of this tangent line right here. If equation of a line, point is given, slope is your derivative. In the point slope form, this is what we have learned in college algebra, that's how the equation of a line look. Y minus y1 equals mx minus x1. So that's the point right here. X1 is -4. Y1 is your plug-in. This is my function y equals 9x squared. So Y1 is when you plug in Y1 will when you plug in 9 times -4 squared, which is a -144. So this point is pretty high, which it doesn't seem like in this picture, but it's -4 minus 144. So that's where, sorry, plus 144, not minus, it's positive. So that's where this is coming from, y minus y1. So y1 is 144. X minus x1, x1 is -4, so it becomes a positive. The slope at this point is calculated using the derivative, which is 18 times x. So your slope m is 18 times -4, which goes in here. And then you solve this equation, y minus 144 equals -72, which is this x plus 4. Distribute a -72, so that becomes a -72x and -288. Add 144, so that's the equation of the line. Y equals -72x minus 144. It's a negative slope. It's coming down. Negative 72x minus 144 is the equation of the line. Now, if I can see if I can plot it, if not, it's kind of stuck here. So I think, okay, yes. So let's plot the first one.